In progress.
All right, welcome back, everybody. I want to go over a new topic today. It's called hash functions and hash tables. We will build more on this on Friday. Today we're going to use, I'm using, map isn't part of it, but hash functions work a lot like maps. So I just wanted to, refresh your memory. Maybe we could make a map function that the key value is like an integer and it stores a string. Maybe, and we'll call it my map. So key is an int, and value is a string. And to make it a little bit easier, I'll give that integer a value. We'll start off maybe saying it's 110, 115. In fact, let's do 115. And we'll say map. Remember, with maps, we can treat it like an array. So say map user page equals it's a string once upon a time. Now that seems like a page one thing. And the hero lashed out in anger at the villain. Why is it marked? Let's see value. Oh, try that. And I called it map, not my map. That's what's going on. There we go. Shouldn't cause any problems if I run it. Nothing's going to see out. We don't have any see outs going on. Just making sure it's compiling. We could add some more pages. My map, page 1, has the once upon a time in a faraway land. There lies a sleeping dragon. And we could add, something more. The hero was born in squalor, hated by many. Him. And we've maybe that was, we'll put this on page, I don't know, 32, not page 2. Stuff like that. And we can do something like see out my map. They have a size function on this actually. See if it says 3. Yeah. And if I wanted to see out a particular page, see out my map. There we go. So maybe we would make it. That's probably not a good way to do it. Maybe we should do if my map and we pass it a user page. We should say if it doesn't equal the empty string, then see out my map user page. because we got to think about what's going to happen if the person using the program doesn't know. Else, see out, page not found. So it was wrong. That should work without it. Actually, make it look like 2 lines, but probably easier to read like that. We could make that a print function, but we're not here for maps. Make sure that works with 115, and then we'll change it to be we'll say user page equals 10. Page not found. There we go. Okay. So this is kind of handy because when we're doing this is like O1 lookup. It's not dependent on end. On the map size. So we could, that's what's really, really handy about maps. It's an array. So we can go straight to the entry. It's not a lot of work. But there's something that's a little bit more versatile. And we're going to switch from this. Next, we look at maps. Or next, look at hash functions and tables. So let me give you an idea of what's going on here. I'm going to use, let's say I'm going to create an array, my array, and it's going to have 10 elements in it. So we got a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So rather than storing a single object in the array, though, what we're going to do is in each one of these, we're going to have a vector. We'll have a vector in each one. And vector allows us to have an array. We have the nice array structure where we can have a fixed size for maybe like sorting, a preliminary sort. But the vector allows us to keep doing something like pushback, where we can add to it indefinitely. And so this is kind of handy. We could do this with a map, though. What the difference is, a hash function comes up here and says, okay, you want an object to be stored, whatever it is, and we'll start with integers, something simple here. The hash function does in an O1 format, decides on an array decides on the element to put it in. So let's say I make a list of numbers. I got 107, 432, 51, 74, 89, 39, 22, and let's go 68. And maybe we want to like decide, like we have a large list of numbers maybe. And so what we're going to do is we're going to pick our index. The index will be the first number. So 107 will go in this column right here. 432 will go in this column right here with the 4. 51 goes here. 74 goes here. Maybe we should have another one. 13 will come over here and go in 107. How can we do this? That's actually going to be harder than I think. Let's do it off the last number. I'd rather make that actually sounds like a good project, a good assignment. We're going to do it off the last number. Because it's not too bad when we're only having like a 2-digit number, but if it's an indefinite series of numbers, unless we treat it as a string, and I don't want to do that, we're going to work on with the last numbers. And so the hash function will take in the number and it will spit out the index to put the number in. So those won't be the same numbers. 107 will now go in 7. 432 and 22 both go in 2. That actually does sound like a fun little assignment for you guys. So let's come back over here and take a look at how the hash function works. So it's kind of like, it's like a map. We've got an array. It's an array of sequence containers. We could use an array of arrays. That's not as pleasant because then you can't just add to it at will. So having something like a vector where you can just add onto it as you want works pretty well. So how could I go about doing that? Let me comment out the map stuff. I'm not using it right now. That was just to get your head in the right element here. Let's go. Let's call it's going to return an integer for the index. And hash functions usually have the word hash in them. Hash, let's call it hash last digit. And we're going to pass in an integer. Pass in an int. You know what? Rather than doing separation, I'll put it all right here. Of course, when you do homework, you should separate, but we're going to just do it all right here. So, like, how do I get the last digit? One way of doing it is we could have it turn argument modulo 10. That should just give us the remainder of dividing by 10. So this function returns the remainder after repeatedly dividing by 10. So this will give us a single digit. And I'll come in here and let's see. I'm storing vectors here. So I need a vector of integers for my array. I'll just call it hash table for now. Hash table n. Let's give it a constant size. There's 10 single digits. What the fuck? Okay, so we can go, like the idea here is like hash table 0 would push back, like a 250. Something that ends in 0, hash table 1, we could push back 31, something like that. '64 is square number. And maybe we should have a little printout. Print this out. Let's just make sure our table setup working well. Let me add a couple more. Let's add a repeat. Hash table 0. Push back 70. Hash table 0. Push back 20. And one more. Why not? All right, we got a bunch of things in our hash table right now. We do for int I equals 0, I less than size, I plus plus. Let's see. Then I need another one for int j equals 0. J less than hash table bracket I dot size. Because that's a vector, that'll return the size. So if there's nothing in it, it won't do that row. We want to see out hash table. We are in the ith element. There's a better way to do this, not like that. Let's undo 4. No, that'll work. See out hash table I. Keep doing that at j. That'll go well. And maybe we'll say do a see out for each one. For bucket I And I'll start off with a new line. Let's put some space, vertical spacing in it. I think that should print them out. Let's see. So let's trim down on the slash n. It's a little bit too much. So for bucket 0, 250, 70, 20. So it's spitting them out. That's pretty nice. It looks pretty nice. Now it's not sorted here. And we didn't use our hash function yet. So we got this hash last digit thing. I'm going to say int key equals hash slash digit 250. Oh, wait. Let's do this. My number. Nope. Value. It's called value. So I'm going to try to redo this with the hash function. So int value equals 250. Int key equals that. And what we're going to do is we're going to do hash table key pushback value. And presumably I should have a similar list. In fact, I'm going to comment those out. And we're going to copy this. Actually, I'm going to copy it, but I need to get rid of the int thing. We'll reassign value each time. Put some numbers in, 33, 51, 17, 41, 111. And now what it's doing for each of these, it's going ahead, it's going to, like 250, it's going to pass 250 into hash slash digit up here. 250 should return after modular division of 0. So it's going to say, okay, in hash table element 0, push back 250. In element 0, push back 250. Here, the key determines the hash function does modular division. It's going to return a 3. And so here in element 3, push back 33. That's kind of like what's going on here. Let's see how it turns out. I got a few that are in 1. Most of the other ones don't have repeats though. So look at that. That's what a hash function does. This has, oh, I want commenting. This is O1 operations. It's not dependent on size. And yet we were immediately able to sort something not dependent on size by doing a math operation, which takes a lot less. So we could come down here and do like you could do a user lookup. Let's add in uh, int user input. And out which bucket your number is in. For an integer. Do a cout. We don't have to search for it. All we need to do is find the bucket it's in. So this is hash last digit user input. So let's say we enter 41. Tells me 41 is in bucket 1. We could make this a little bit better rather than hard coding these in. We can do this. Let's do like a for loop. For int j equals 0, j less than 250, j plus plus. Value equals rand or 1 plus rand mod 500. Do 1 plus rand mod 100. It will go 400 here. And maybe rather than having an end line here, we should probably just have it put in a space. Otherwise, we're going to have a lot. So right now, value is doing that. And now we're going to say, we're going to throw, let's grab this stuff where it doesn't have all the commenting. That's fine having it pre-assigned. Then I'll comment all this out. What key is that? Display quick info. Don't want that. Let's comment that out. So I should have randomized what's going in. It's putting in 400 numbers. I already don't like it. Let's do less numbers here. Let's do 200 numbers. And I think we need that. I think we need another /n here now, since I got rid of the end line. There we go, a little bit more readable. We can see like on bucket 1 showed up a couple times, 3 times. 71's in there a few times. Oh, this is terrible. I don't have an extra cout at the end. But let's say I want to find 17. 17 is in bucket 7. So it's going through and finding out where everything is. And do we have a 48? We do have a 48. 48's in bucket 8. And we have a 46. 46. There's a 46 in bucket 6. No, there isn't. There's no 46 in bucket 6. So what I just did is showed where it should go. This isn't right. So this is saying where it should go. So we'll look at doing some more with that in a little bit. This doesn't seem like a very realistic operation, putting things in spots by a last number. So maybe we could kick it up a notch. Get rid of all this crap. Get rid of all the mind map stuff. Something we might work on might be a string or something like that. So maybe let's include string. And we'll make a function that returns first character. So maybe we will, I can do char equals arg0, char temp equals arg0. That should be the first character in string. I should probably look to lower it. And what's the ASCII table looking like? Where is the where does the lowercase level letters start? 97, I think. 96. 97 is lowercase a. So we could have this, like, we could cast this as an integer. We could return 97 minus int of temp. So like if temp equals a, it's returning 97 minus 97 equals 0. Yeah, let's do that. Let's have it do that. Comment out that. We don't need to do the random thing. I'll leave it in there for looking at because I like this key value thing. In fact, doing key and value, let me do that real quick. This can actually all be done in a single step. The reason why I did key and value is I wanted you to see how it looks, how it relates to a map. Map has the key and value. We could just as easily say hash table, hash last digit of value, push back value. This line right here, this line does what the previous two lines do. There is a way to shorten your code a little bit with it. Now I'll comment that out. You just, what you're doing is you're taking this part right here, and rather than setting it equal to key first, you're just putting it right inside the bracket. So here we're working on doing one with the string. So maybe I need a vector string. String table. I don't want to start it with string. My string table. And we'll do a constant n here. 26. So rather than hard coding a bunch of names, maybe we'll do like, let's make a temporary string here. Call it user string. And we'll do a cout. What names would you like to store? What name would you like to store? If you're done, just hit enter to stop. That's a long way of just saying hit enter to stop. We could do a we need to do a get line here. Get line cin user string. Do a cin.ignore just to make sure. So user string has like the user's name in it. Now we've got my string table. We're gonna do my string table, and we're gonna tell it to actually I'm gonna use key again real quick just to make sure everything's working. Key equal, what did I call this thing? Hash first character. User string. Oh, I'm putting the key here. And it's a vector, so then we're going to do pushback user string. We have our printout. Here I wanted to go up to size n, because n was the letters. There we go. That's another way right there. Let's just see if that goes, that works. Doing one. I've done a lot. David. Some didn't work. Make sure it's spin back the right thing. Spit out -3 for D. Oh, this is getting to be a bigger number. I need to do this in the other order. Int temp minus 97. Should be going bucket 3, but it didn't go in bucket 3. Why not? Oh, my for loop is printing out the wrong string table. So I'll copy that, put it up here. Then I'll comment this one out. And this is called hash or my string table. That's what's wrong. Okay. Make sure it's going in the right spot already. I fixed that thing. That was nice way to check to see what it was. Oh, Veronica didn't get a bucket. That's fucked up. I added the name, so why did it do that? Oh, I only had a. It's not a. I don't have it under a do while. That's why. It's only doing one name. So let's put this in a do while. While user string does not equal the empty string. Now I should be able to push back a bunch of names. David, Kenny. Oh, I don't like it. I think the C and ignore is pissing it off. Try this again. Oh, exception thrown. Oh, Yeah, we got to go back and like tell it. Let's see. If user string does not equal, it doesn't like the empty set one. Then we'll do the key and the hashtag. All right, let's try that again. I think that's what was pissing it off. All right. All right. So bucket zero. Maybe saying bucket zero isn't very helpful. We can tune that in a second, but notice the D is going in all the bucket threes. This leads me to a toss up here. A is the first letter of the alphabet, but it's going in bucket zero. We have a couple options to deal with this. Does that, do you guys see that? Is that like David is the fourth letter in the alphabet? D is the fourth letter in the alphabet, but it's going into bucket three. C is the third letter, it's going into bucket two. I don't know about you guys. That bothers me. Uh, like, there's a couple solutions to that. We could make n equal 27 and leave the zero array zero part empty, array zero vector empty, and store character names by their first character number. Like A equals 1, B equals 2, that kind of thing. Or we just say fuck it, leave it on the back end. There's a couple ideas here. Like for me, if it were for me and the memory, even then, it's just one empty vector. I don't know that it's a lot. It's not adding a lot of memory. If it were me and my memory, I'd say add the zero and leave it empty. Maybe even use it to store non-zero characters, non-letter strings that don't start with a letter. Uh, or if we need to save memory, the other way is maybe we shouldn't say bucket I. Maybe we should say and call this char I plus 97. 97 gets us A, I equals 0 should give us, it should now tell us the letters. Entering a bunch of names. Let's stop. And now look at that. It's giving us, now it's saying what the bucket is. So bucket is the unofficial, well, no, it's not the unofficial, it is the official name. These are called buckets. Because we're just throwing anything that starts, like, we're throwing anything that starts with an A in bucket A. Like if you went down to Lowe's or something and bought buckets, 26 buckets, and you had these names on a slip of paper, you would throw them each into a bucket. They call them buckets. That's just the thing that they like to call them. So they're called buckets. But this is how, notice how what this hash function is doing. It's just a function, and it takes in the string. This is taking the first character. It doesn't care how many characters are in the string. It just grabs the first character, it lowers it, and returns a number. This is order one lookup. It's an O1 operation, not size dependent. So it doesn't eat up a lot of time or anything like that. It's efficient. On these hash functions, first off, have hash in the name somewhere. See a chat thing. A bucket of buckets. It's a good question. Could we have a vector? Let's look into doing this on Friday. Because I want to do an object where we do like a person instead of like a name string. But maybe we could very well set it up where it's not like an object, not like a person class, but we set it up where it does it by last name, and then all the last names have their own vector, like a vector of vectors in an array. I don't know. I want to say it's possible, but I haven't tried it. Let me think about setting up something for Friday that's quicker than doing the whole class thing with the person. But I do want to show putting like non-traditional classes in here. That'll be for Friday. Here, this is just getting us used to the hash functions and how these things kind of work. On the hash functions, first off, have hash in the name somewhere. It lets people know what it's for. Second, try to have as few operations as possible, especially if they are dependent on size. You may end up being forced to have something that's dependent on size. In this case, we were not. We did mathematical operations on all of these. That keeps this efficient. We want to keep it efficient. Now, if you noticed, these aren't sorted. Keith is after Kenny. Valiander is after Veronica. Do we have sort in vectors? I don't think we had sort in vectors. Pretty sure we didn't have sort in vectors. No, we don't. But we do have something that works like a vector that does have sort, which is list. List isn't showing a whole lot. List has a sort. Did I go up and down far enough on vector? Yeah, there's no sort here. So we got a bunch of names here. We manually added, or the user got to type in names, but it didn't sort or anything. So that's a problem with what we have here. Using vectors means we might need to do some types. We might need to deploy another sort algorithm to make it more useful. On Friday, we'll switch to lists, which has a sort and works just like a vector. We'll also look at objects, at user created objects or classes, and other ADTs, abstract data types. And let's explore buckets of buckets. Now, you know what? Yeah, we'll explore buckets of buckets. I got an idea on how to do that. We could it'd be pretty easy with 3-digit number. Have the first row of buckets stored by the first digit by doing. In fact, I'll even show you on what I'm thinking of. What I'm thinking of trying for that thing is like, let's say we've got 327. We would have like, and we're doing it by first number. So 0, 1, 2, 3. 327 would go in here. But we don't have 327 here. This has its own array of 0, 1, 2s and shit like that. 0, 1, 2. Then it takes the 327 and puts it in here. So that way we would have, in each of these would have a 10 element array, like an array within, it's like a multi-dimensional array, then with a vector list. Huh. Because the way you set these up, we're doing like this says a table of vector integers. Can we do a vector of integers? It doesn't say no. So Veronica, on that, would you sort by name then gender, or gender then name?
I was thinking name then gender because like when we had gone through the last one, I was like, oh, well, is it possible to like sort all the V names into like separate buckets of a boy and a girl?
Okay.
That was what made
We'll have to
me
check
like,
we'll have to
oh,
check that out. Notice that I was able here to put vector inside a vector.
hmm.
It's not saying no, which to me is a good sign. But like, how does it know what this vector is? This vector is supposed to be an integer vector as well.
That's what I was gonna ask also. Do the vectors have to be of the same data type?
Well, the way I was thinking of it, it would, but like yours would be, could easily be a Boolean versus a string.
Hmm.
I don't know. Let me look at some of that stuff up for Friday. See if we can expand on what I was going to do for Friday. Friday we're gonna switch to lists, so we have sort. We're going to add in doing user made classes or programmer classes like we've done person stuff like that. We'll look at it deploying person in here, and then we'll see about this multi-level stuff because you can do arrays of arrays. That's just called a multi-dimensional array. Should be a multi-dimensional vector, and if you could do a multi-dimensional vector, we should be able to do a hash function for it because the array would just store the multi-dimensional vector. Is there? It's just plus plus multi-dimensional vector. So vector vector n. So this creates a matrix. That's effectively what we're making. But in each thing, we're storing a vector, so the list can keep getting bigger and bigger and bigger. It looks like we can. Because that's what a matrix is. This is a vector. This is a different vector. This is a different vector. And they're all stored in one big vector. So it's a vector of vectors. But I think we're going to be able to pull that off. So maybe we'll look at like what does our class have right now? We got person class. I know we keep saving it up here in this thing. Did I put one in binary search trees? Nope. Did I not upload one? November 3rd. It's got person. What do we got in person? So we got gender in here. I don't the like we're gonna look at doing a multi sort like that with the because we've got gender in here. We could also do by last name, then sort by first name. There's a lot of ways we can do it. I like checking out like maybe last name, doing all three. Maybe let's see what we can do for Friday. Make this like interesting. Because the topic in itself, once you understand that what we're doing is we're making just like this is like a lineup, and now the vector can be of unending length. This one could go on as long as it wants. This one could be really short. This one could be medium, short, super long, short again. It just depends on what gets stored in the box and what we keep adding to it. Like even with names, some letters we're storing them by first or last name, first character. Some letters just aren't going to get the fucking love. Q is not going to get the love that S is. You know what I mean? For either first name or last name. So the Q bucket is going to be pretty small. So we'll look at what we can, how to expand upon this. The idea we're taking from here tonight is this hash function thing where we do some sorting and stuff like that. Because you saw that binary search tree, our when we did the sorting in the binary search trees, like best case scenario was log n, that kind of thing. If we can get down to O1 sorting, which is what we're doing here, we're doing O1 sorting, it's much more efficient. And that's the point of doing these hash tables. That's how come Google and Amazon and all the things that you look up that has fucking thousands and millions of entries, that's how they get away with being so fast. These hash function ideas. And I bet they do deploy exactly what you're talking about, Veronica. Multi-level hash function things. That way, in fact, I bet that's how Amazon, we look at Amazon right now. Their first buckets are listed right across the fucking top. This immediately takes us to a category of products. So that's the same idea here. So if we click on groceries, now, oh wow, there's a subgroup of groceries. So here's the buckets in buckets. Click on beverages. And so on and so forth. Does it make sense? Play around with this. I'll load the code up tonight. Play around with it, explore it. I think you'll get it. I think you'll like it once you got it, because it does give us access to making our entire own database. We can make a database as large as we need it to be. We don't have to say what size it is ahead of time. The penalty of using arrays is negated here. Even though we're using arrays, the penalty of using it is negated because we're only using the array to do a preliminary sort, and then we're storing everything in a vector or a list that has unlimited add-on capability by the user. Plus it has cheap sorting and searching and stuff like that. Being able to do like the my map thing, being able to type in the key is pretty handy. This is much like that. Other than that, that's what I got for tonight. Any questions about hash functions? Let me go copy paste this in the announcement. Oh, let's get rid of some of the extraneous space. I guess I don't need that. All right, I will stop recording.